CIT 1122, Module 1, Sub-Module or Section 3, Securing Remote Access. This is getting into Secure Shell and SSH, which is a better form of remote communication through TCP/IP than Telnet, only because Telnet had no security built into it. And they do a really nice job of showing you that here. So everything that we've been teaching you so far, we're like, set up passwords for remote access. And you go line VTY 0 space 4 or 0 space 15, and then password, and then login. The thing is, when you send your credentials across TCP/IP with Telnet, those credentials are sent in what's called clear text, which just means that if you are running Wireshark, as they're trying to show you here, the username would be in clear text, which in this case is XTeam, it looks like. And then the password is also clear text, and in this case, that would be CCNA. So if someone was capturing information, on a wired or wireless network, and they pull that down and they see this transaction between your device and your Cisco device, then you would say, oh, hey, look at that. I know the password now. And someone that would steal this information could then log into it. So that is an absolutely unnecessary risk to take on your network. So we're not going to use and set up Telnet on anymore. We're going to go ahead and set up SSH, which is just a more secure front end on something that does the exact same thing. Because when you Telnet into it, you have full access to the CLI. And when you SSH into something, you'll have full access to the SSI, or the CLI. So that in the end, it's the same, except for one way you send a secure password and one way you do not. So the way that SSH works is it creates a key pair, and the key pair are basically work like this. You're going to have a public key and what's called a private key, and the public key you give out to someone else, and then they use the public key to encrypt their information, and then they send it back to you. And the only key that can unencrypt anything that's encrypted with the public key is the private key. And since you're the only one with the private key, you now have a secure form of communication between devices. So that's where SSH comes in. So there's some really good labs. And this is just the overview on how it works, and you can see show version to see if you can SSH onto your switches. Some you can, some you cannot, and then it gives you some steps here on how to set it up. Essentially, there's a lab. I think it's 141, and the video is done for that one. It's the very first lab for this chapter that's posted, and all you do is set up SSH. So you have to set up a domain name. You have to build your key set, so you make your key pair. Then you create a username. You got to make sure you have your privilege level password. All that stuff has to be done. You'll do that in that lab. So I'm not going to go through all the steps in this video because it's just too redundant. But that's where that piece comes from. The next section gets into basic router configuration, and I'm going to kind of mail this one in also. The basic command lines you should know already. And if you need explanation on these, I think the best thing to do is just to do them. So I think it's lab like 147 or something like that. The next 2 or 3 labs, really the next 3 labs in version or in module 1, those videos that are all posted on YouTube, you can watch those videos and they will walk you right through configuring and what's global config and what's privileged and what's user and the basic command sets that you need to know. Also, you should have learned these in 1121. So this should be no great shakes here. Setting up banners, you should understand the delimiting characters that just begin and end the banner. So right here, banner MOTD, message of the day, MOTD, and then delimiting character $, which just means this: anything you type after $, is the message. And then when you type in $, again, you're saying that ends the message. So that's what they call a delimiting character. If this message had a $, in it, then that's where it would end. So just keep that in mind. It doesn't have to be a $. It doesn't have to be a hashtag. It doesn't. But if whatever you type in after banner MOTD, That's your delimiting character. So generally don't use a letter. Use something you're not going to use in your messages. Okay? All right, so keep that in mind. Dual stack topology, this just gets into the idea that you can have routers can run two different addressing systems. There's IPv4, there's IPv6. Dual stack just says this. You can run some traffic across IPv4, other traffic will run across IPv6, and really the addressing, information will not interfere with each other. So when they say dual stack, sometimes I think one of the best terms I heard about IPv4 and IPv6 is they say ships in the night. Ships in the night. And ships in the night just means that you have two, if you think about ships in the night, they could float right next to each other and never even see each other. They're not going to interfere with each other. And that's the same thing with IPv4 and IPv6. So you can stack everything up with both addresses, and you can pick which one you want to use first. Usually they say IPv6 if everything's set up. You can fail back to the other one after that. Configuring interfaces, once again, this is stuff you can do in the labs. We have videos provided to walk you through those packet tracers. And there's some more of that. And then this is something that maybe was missed in 1121 or maybe didn't get communicated. It is the concept of the loopback interface. So the loopback interface is what's called a logical interface as opposed to a physical interface. We are used to, on routers, having physical interfaces. G0/0 is a physical port on the device. G0/1 is a physical location. You plug into it, and then you configure it as such. The loopback interfaces, you can create them on your own, and there's a myriad of reasons you might want to use a loopback interface. We'll talk about those in other videos. But to create a loopback interface, really, really easy to do. Interface, loopback, pick a number, hit enter, boom, you just put an address on the device. One of the things you might want to use it for testing in classes. Sometimes router ID value would be better off of a loopback interface. But they're just they are virtual interfaces that the router thinks are real, is really what it comes down to. So that's basically that. And then section 5, 1.5, verify directly connected networks. This just gets into show commands, and you should be aware of these. Some of the show commands I like to use, especially in CCNA class 1 and 2, show run, show IP interface brief, which they're showing here, and show IP route. Those are your money makers. Those are the three show commands that you need to be able to look at and decipher and understand what's being said. As far as anything with IPv6, they do show some IPv6 in here too. And one of the things that's new for the new version, is they do show you how to use piping, where you can filter some of the information in the show commands. They show you that in the labs these days, so that's pretty cool. So go back and watch those videos, or do the labs, do the packet tracer labs that are associated with this chapter, and you will see some piping. So you'll see a pipe with a begin, and you'll see a pipe with an exclude, and it just helps filter out the show command, so it's not as much stuff to look at, which is pretty cool. It's a pretty cool thing. So keep that in mind. I don't think anything super exciting. Show run, we know that. Show IP route, you're familiar with those. Just a quick thing on show IP route. Show IP route is going to show your IPv4 routing table. Show IPv6 route is going to show you your IPv6 routing table. And you can see here on this particular slide, they do have a bunch of C's and L's, and you'll notice that the C's are the connected networks. So in this case, 192.168.10.0/24, that's the network that's created, and then the L for local is the actual interface value. So 192.168.10.1 is on interface G0/0/0, but any information that shows up at the router that needs to go to network 192.168.10.0 would be forwarded to interface G0/0/0. So hopefully that makes sense. They just added the L's a few years ago. Local links didn't used to appear. It would just be the C for connected. I think it was a little more straightforward to think about, but it is something that's there. Also, if you have an interface that is in a down state, so if we went into the config and went to G0/0/0 and typed in shutdown, then this entry in show IP route would be eliminated. It would disappear. And if we went back and did a no shut, it would come back up again. So if an interface is down, even though it's got an IP address on it, if it's in a down state, it's not plugged in, or it has administratively been set to shut down, it will not appear in your routing table. Kind of an important, it's kind of one of those important things. Not much more on those. This is filtering. We just talked about that. Command history feature, that's in the labs also. And that gets us to the end of Module 1. So that was parts 3 and 4 and 5.